Hello, welcome once again to today's class. Um, Thank you very much for following all through to this point, and I tell you that there is progress. Um, I'm talking to my students who have been following me, whom we are learning together in a group. If you are just joining, uh, just know that I have a coaching group where I'm grooming students that will we are working together to achieve high score in JAMB in 2025. If you wish to be part of us, uh, drop I want to be part of your class in the comment section below, and I will find a way to add you to the group. Thank you so much. If you are my student, I Okay, let me be specific here. If you have been following, well done, you are doing well. And I tell you, there is progress. It may look as if, I hope I'm learning. Yes, you are learning, let me tell you. In as much as you are following, you have been doing all the assignments I've been given, you have been uh, carrying out all the tasks, following and carrying out all the instructions I've been given. I tell you, you are not the same as you used to be, except if you have not been active. And I'm already working towards seeing how to uh, remove inactive members from the group. Yes, through our housekeeping. Uh, some people don't need to be part of us. I said I only want to work with serious students, and I'm happy I have some among you. So those that are not, they have to excuse us sincerely. I cannot give much time to people that are not serious. I am a very busy person. So if you know how I used to squeeze to attend to you, to create videos for you, you would really know that I'm trying for you people. But then I have a goal to have many students. My target is 250 that will have 250 marks and above in JAMB this year. Um, Even though I don't even have up to that number of students in my group, I still believe because I'm working hard. And thank you to all my students who have been working also to help me get more students by reacting to my videos, which will help it go to others, help the YouTube show to many other students. So I want to appreciate you for that. Those who have been talking to others, their friends, and are bringing them to join the group. Thank you for all you have been doing. I really appreciate you, and I didn't take your effort for granted. So thank you so much. And how was yesterday's assignment? Challenging, right? All right. You may not understand whether it is challenging yet until we do today's mental drills. And let me advise you, don't miss it. Oh. I know my students. I know my students. I'm proud of you anywhere I go. See, I'm confident that some of you, even at this point, if you go and write JAMB, you will have high marks. I'm sure. I'm sure. So I'm so happy. I believe that my effort is going to pay well. Yes, I'm going to have students among from my own class to be among the best nationwide. That's my goal. I've told you my success stories in academics. Yes. Even while I was serving, I wrote an exams, yes, on a professional course, and I emerged the best in that state. I don't know if they had collated exams nationwide. I believe that I will still be found among those top students. Yes. So it is possible. And welcome back. So let's look at today's questions, even as you prepare yourself for mental drill. Now, mental drill questions will be centered on this video and that of yesterday, so watch each carefully. If you are just joining us, mental drill is part of our strategy to train ourselves in active recall. I explained it. Several students will go to JAM. They are brilliant, but they cannot write anything. Some, they become confused. Some, when they come out from exams, and several times people have been complaining to me, that I don't know, when the exam started, I just felt as if everything went out of me. And some people will go as far as saying village people are following them. Hey, it's not village people anywhere, I tell you. Most times it's stress, most times it's because our brain has not been trained, yes, to act in that kind of environment. Even in the university, I've told some of you that I'm a master's student. I've enrolled for my master's MSc and I'm on it. When I wrote the last exams, one of my colleagues came and said, I didn't know what happened to me. She said she went blank. I don't just can't understand what's happening. So I don't want you to be part of those situations. So if you are joining us, mental drill is part of our strategies of training mm, our mind, our brain to recall even under stress, to be able to handle stress, to be able to write even in an intense, even in a hot environment. And my students have been catching up with that. I'm so happy with that. One thing I'm confident about them is that not only are they brilliant and getting better and better on daily basis, but they are also developing those skills of problem solving. Yes, this is the sweetest part of it. This is the one that impresses me most. Many of them are not afraid to take challenges. Some people, even I made mention of it yesterday, even some coaches, they don't talk about calculation aspect. This time around, I'm emphasizing it. This has been one of my videos, including yesterday's one, that talk about calculations in physics. So I want to emphasize it. I want to train you in every area. I don't just want to show you questions that theoretical, no calculations. No, 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 no. That's not a good way. That's not a good way. So you have to learn to take challenge. Even many students avoid calculation questions during exams. And you cannot avoid problem. I say even in life, you cannot avoid problem. If you try to be avoiding problem, the problem will keep chasing after you. That's just the truth. But what do? You confront it and it will run away from you. Some of the things that appears hard to us is because we don't try. We don't like problems. So if you are new here and you are joining us, I think the best advice I would advise you is to find a way to connect to my training group. Yes, connect to my coaching group. That's where you get the best. You will learn from this video quite all right. But then, if you are part of us and you are serious to be able to carry out all the tasks, to be able to follow the instructions, what is JAMB again? See, all these exams, they don't used to. I have shared several of my success stories. So let me not waste much time. Let's get right into it. Again, if you are a new student, if you are just coming across this video, find a way to connect with me. Drop a comment on the comment section that indicating your interest that you want to be part. I will see how I will add you. That's the best. Mental drill is just one. It's just one. Our assignments and other things we do, and I'm planning also to bring up several things with the goal of training my students in different ways. I just want them to be very flexible. No matter what, they will be able to navigate the challenge, the problem, and come up. That's what life is all about. It's about solving problem. So not only will they succeed in this jump, they are also going to excel in life, because life is all about problem solving. You have problem in your house, in your family, your ability to solve it will determine how right things will go and continue to go in the future. If you are unable to solve any problem, the problem will remain. That's just the truth. So thank you once again for joining me if you are my student, and God bless you. So let's run through today's questions. I intended to bring only calculations today, still under motion, emphasizing motion. I want you to understand every part of motion so that any question that JAMB will mistakenly, let me call it mistake, bring up under motion. You just smile and say thank you, thank you, thank you, thank you. Yes. All right, so that's it. I intended to bring only calculation questions, but I felt No, the calculation question under the year I am considering, which is the last year JAMB pass questions. Yes, they are what we are going to discuss today. So just to give you the most recent format of JAMB pass questions, it will give you a hint on what to expect this year. So, um, I had to bring some few theory questions, but note that mental drills may not. Should I give you this expo? All right, let me say it. Mental drill may not have theory questions. All the questions on mental drill today may be calculations. That's why earlier I told you today's mental drill is is a big challenge. But I know you like challenge. Yes, I call you. I call us those that challenges challenge. Yes, so I am sure you prepare yourself towards it. Thank you very much. Let's go right into it. So the first question here says, what must be changing when a bus is accelerating? What must be changing when the bus is accelerating? Now remember, what's the definition of acceleration? Change in velocity. The rate of change in velocity. If you use rate, you are talking about with time. So if I say velocity is the change in velocity acceleration is the change in velocity with time, or I can say is the rate. I have already included time in that rate. I hope you are getting my explanation. Is the rate of change of velocity. So this thing is very simple now. Just know the definition. By definition, already we know what the answer is. They say what must be changing when a bus is accelerating. What is acceleration, by the way? Acceleration is the change in velocity with time. So velocity must always be changing. Do you see how simple these questions are? You know, sometimes I will sit down and say, these people, why are they asking this kind of simple questions? But guess what? Some people cannot answer them. I tell you, that's just the truth. You are going to do well this year. Keep following. Keep closely following. I will make sure that you get a very high score. And not only that, you'll be prepared for any other exams that may come your way again. That's it. I am never afraid of exams. I've written many exams in life. Many exams in life. So I'm no longer afraid of any exams. If you are not afraid of any exams, you go in with confidence. As in, while people are sweating, you'll be smiling and be asking, what's wrong with these guys now? All right, so that's where we are going. Keep following, keep tight. Don't come today, tomorrow you are there, next tomorrow you are not there, the other day you are there, just like that, up and down. No. Consistency is key, and I've been emphasizing this. If you are a new student, subscribe to this channel. Connect others, let them know. I'm still looking for more students that will join my coaching class. It is free, you don't pay anything. I have a goal and I'm committed to that goal. Having students that will have 250 and above in their JAMB this year. So it's a goal that I'm working on, and that's why I'm committing my time, my resources, my energy to try to see that I have achieved that goal. So if your goal also is to score 250, 300 and above, you need to also make a commitment of following closely, a commitment of carrying out all the tasks I will give. Let's go right into the next question. What would be the weight of a bowling ball on the moon if the moon's gravity is... What would be the weight of a bowling ball on the moon if the moon's gravity is 1/6? That's 1/6 of Earth's. Okay, so this is talking about weight now. And you know that weight is equal to mass times acceleration due to gravity. I hope someone is writing this formula down. Before later you'll see a question. Why am I giving these guys expo now? Oh, all right. So just know that weight is equal to mass times gravitational force. Don't be surprised. I've seen this kind of questions in JAMB where they will say the mass of an object is this. If the gravitational force is this, what is its weight? So I've given you, note that. This is why my tutorials are different. This is why my coaching is different. I don't just answer questions. Before I will answer, see, observe. These questions I'm answering, you observe that in one question, I will answer like 3 or 4 other questions around that question. So if you are careful and you follow carefully, hey, even if any question Jambo asks around that area, you'll be able to answer it. All right, let's go. Now, the force of gravity varies across different planets, even in different locations. On Earth, it is usually given as 10 meters per second. 10 meters per second. And sometimes 9.8 meters per second. And so on and so forth. Now, some of us might have heard that in the moon, you drag the astronauts that goes to the moon. They don't walk or they can't jump because the force of gravity there is small compared to the earth. So if you jump, since the product of mass and acceleration due to gravity is what gives weight, which is able to bring you down, and now the force of gravity is near to zero, it means if you jump, you cannot fall down. Yes, so that's the physics that is working there. So now, the weight of an object on Earth, the weight of an object on the moon is 1/6 of its weight on the Earth. I've already answered the question, though. All right, so we have a bowling ball on the moon, and its weight is 1/6. If the gravity in the moon is 1/6 of the Earth, so the weight will also be 1/6 of its weight on Earth. Let me use a simple illustration so that you will understand. Let's say an object weighs 60 kilograms. 60 kilograms on Earth. Now, if the force of gravity, gravitational force, on the moon is 1/6 of that of the Earth, that is not even up to that of the Earth. So what will be the weight of this object there in the moon? Remember, on Earth it is weighing 60 kg. So it means on the moon it's going to weigh 10 kilo. Do you see the difference in the weight now? I hope this is clear. Please, any question I treat here that is not clear, don't hesitate, don't delay. Write your question. Say question 3 explanation is not clear. I will take my time to attend to you. Just drop it in the comment section. So let's assume a question may come this year that the gravitational field on, let's use another planet, on Pluto is half that of the Earth. Get my question? The gravitational field or gravitational acceleration due to gravity on Pluto is half that of the gravitational acceleration due to gravity on Earth. If an object weighs 50 kg on Earth, what will be its weight on planet Pluto? Is this clear? Good. So if it is clear, it means that the gravitational force, the acceleration due to gravity here is 50 kilo. The weight of the object is 50 kilo, and the acceleration due to gravity, difference between the Earth and that planet we are considering, which is Pluto, there is half that of the Earth. So the weight also will reduce by half. The weight will reduce by 1/6. If it is 1/6, the weight will reduce by 1/3. So that's how it goes. So which means it will weigh less on those planets. I hope my explanation is clear. Please, like I said, if it is not clear, just let me know. I will explain again. Thank you. Let's go to the next question. All right. Sorry. So the next question is here. And it says, if a body moves in a straight line from point P to Q, what type of motion is this? Remember types of motion: translational motion, rotational motion, simple harmonic motion, and circular motion. Yes. So if you know your types of motion, you would be able to answer this question very well. If you don't know, let me explain. Translational motion has to do with a linear motion, a motion in a straight line from one point to another. And that's why A is our correct answer, because it says a body moves in a straight line from one point to another. That's translational motion. Rotational motion. Rotation has to do with motion around a fixed point. For example, the Earth rotates around its axis. The Earth rotates around its axis. So that is what brings about day and night, changes in day and night. All right, then we have simple harmonic motion. Simple harmonic motion is somehow similar to rotational motion, but simple harmonic motion moves in more like half a cycle, if I will call it like that. Some of us knows our pendulum bulb. Yes, so that kind of motion is called simple harmonic motion. It goes this way, simple harmonic motion. For example, you tie a ball on a thread and you tie it on a record stand, then you pull it back and release it. What happens? It goes forth, comes back, goes forth, comes back, in that order. So that is an example of a simple harmonic motion. So a spring also undergoes that kind of motion, simple harmonic motion. Yes, a spring can go like that, go up, come down, go up, come down, go up, come down. That's simple harmonic motion. Then we have circular motion. You understand this, I believe. Motion that occurs around a cycle. So please note this, note your types of motion. Let's go to question 4. Question 4 has a diagram. They say, what is the effective force pushing an object forward at an angle of 60 degrees? At an angle of 60 degrees. So observe the diagram. We have the ground, we have the trolley, and we have the force that has been applied on it at 60 degrees Celsius. So the force that is acting, or the effective force that is acting or that is pushing this force, though 50 Newton is being applied, but it's not all the force that is pulling the trolley, because the force is applied at an angle. I hope you are getting this. So we have a formula to calculate an effective force that is acting at an angle. And that formula is effective force is equal to the force applied cos the angle on which the force is acting. Hope this is clear. You need to know this formula. The effective force acting on an object, when the force is placed or is working at an angle, the formula you use is the force applied cos the angle. If it's 60, if it is acting at 60 degrees, cos 60. If it is acting at 30 degrees, cos 30, and so on and so forth. So I have it here worked out. So the explanation is there. The horizontal component of a force is calculated as F cos 60. F stands for the force. So here we have seen the force, which is 50 Newton on the image, 50 Newton. Therefore, we get 50 times cos 60. Now let me quickly say this. There are some things you need to know which are always constants. When it comes to this cos 60, sin 60, cos 30, sin 30, cos 30, 90, and so on. Please, you should be able to know some of, I'm not saying all, just a few, so that it will save you time. You don't have to look for on-screen calculator when you are writing JAMB. You can just, because you know it offhand, it does not change. It's constant all the time once you know them. So cos 60 is always 0.5. Cos 60 is always 0.5. So if I know cos 60 is always 0.5, from this formula, I will only say 50 times 0.5. And you know what 0.5 stands for? If I'm to change it into fraction, what will it be? It will be 1 over 2. That is half. So this means half of 50. That is 50 times half. And what's the answer? 25 Newton. So that's the force that is acting. That's the effective force that is acting on the object or on the trolley. I hope this is also clear. Don't forget this force. When we talk about horizontal force acting at an angle, the effective force is always equal to the force applied cos the angle. Hey, I hope this is clear. All right, let's go. Let's go. All right, look at this question. Look at this question again. Question 5. Hey, JAMB. People are accessing simple questions. So. All right, I trust my people. So look at this. A body is pulled on a horizontal surface. Do you see something similar? With a rope inclined at 30 degrees to the vertical. 30 degrees to the vertical. If the effective pulling force, do you see something similar? Effective pulling force. We talked about effective pushing force in the previous question. And guess what? These questions appear the same year. So it means anyone that cannot answer the previous question cannot answer this one too. That's just the truth. All right, the other one is pushing, this one is pulling, but they are always calculated. They are similar. All right, so let's go. If the effective pulling force along the horizontal is 15, what is the tension on the rope? What is the tension on the rope? This tension, don't forget, don't be confused. It means force, but that force is acting in form of a tension. It's acting in form of a force that is applied on the rope. Force that is applied on the rope. So the effective force along the horizontal is given by tension. Now, if you are using tension, because we are talking about force applied on the rod now, not on the object, there is a little difference, but not much. So remember earlier we used cos. Now we are using sine because we are calculating tension on the rope, because the rope is the one being used to pull an object along the horizontal surface at 30 degrees. So note the difference. We are calculating tension. Here, the effective force is given to us. Previously, we were asked to calculate it, but here we are given. So we are calculating tension. So at this point in time, you use sine instead of cos. I hope this is very clear to somebody. If it is not, please ask. All right, so we have tension sine 30 is equal to the effective force. Remember, this formula, I just changed it. I just rearranged it. All right, what was the formula we used previously? Can you remember? The effective force is equal to F, force applied, cos 60. The same thing is here. Here, the effective force is equal to tension sine 30. I hope this is clear. Remember, this 15 is your effective force. So the formula being written as tension sine 30 is equal to 15 Newton can be rewritten, can be rearranged as 15 is equal to T, that's tension, sine 30. It's just rearrangement, don't be confused, please. So if we solve for t by dividing both sides by sine 30 to make t the subject of formula, then sine 30 is always 0.5. What is cos 30? 0.5 too. Sine 30, 0.5. Don't forget this. If you forget any other one, these ones, they are popular. You should get them offhand. They are constant values. So sine 30 is 0.5. So 15 divided by 0.5, that will give us 30 Newton. So that is the tension. That's the force. Newton is the unit for measuring force. So that's the force acting on the rope. If you see this kind of question later. All right, so I hope you are ready for that. Let's look at the next question, which is question 6. Question 6 says, if a car's displacement is proportional to the square of time, what kind of motion is it undergoing? Displacement is proportional, is equal to square distance, or is proportional. There is a common factor that exists between two parameters, displacement and time. What kind of motion is it undergoing? This question is somehow tricky, but if you understand the definition of these terminologies, it's very simple. Now, do you know that they are trying to test your knowledge for the unit? That's the angle I'm coming from to answer this question. What is acceleration? What's the unit for acceleration? Meter per second square. You get it? Do you see it? Displacement is proportional to the square of time. What is meter? Displacement. We are talking about distance there. Then square time per second square. Do you see that? So we are talking about acceleration. It is undergoing a uniform acceleration. A uniform acceleration. There is no increasing acceleration, there is no decreasing acceleration, there is no uniform velocity. It is undergoing a uniform acceleration. In a uniform acceleration, the displacement per time square is what is operating. Thank you. I hope you get this too. Let's quickly run through. I don't want to take much time in this video. 7. Given the velocity time coordinates 2 seconds, 5 meters per second, and 4 seconds, 15 meters per second, what is the mean acceleration? Mean acceleration. Now remember the coordinates from your velocity time graph. Velocity time graph. So you have velocity, you have time plotted. So if you are given coordinates, what's the average or mean acceleration? So acceleration, remember, is change. I hope you know that change means difference. And difference means what? Subtraction. All right. I hope my people understand the simple things. So what's the mean acceleration? So to calculate this, we have to find acceleration. The formula for acceleration is change in velocity all over change in time. This is what we are going to use. The rate of change of velocity, that's acceleration. The rate of change of velocity, or you can say change in velocity with time. I have explained what rate means. Rate, once you put rate, you've already put time there. All right. So we use the formula acceleration is equal to change in velocity, that's v2 minus v1 all over t2 minus t1. V2 has to talk with has to do with the final velocity minus initial velocity over the final time minus the initial time, which means the bigger minus smaller, the bigger minus smaller, in that manner. All right, so from our question, 2 seconds 5 meters per second, 4 seconds 50 meters per second. So we are going to have, for velocity, 50 minus 5, while for time we have 4 minus 2. If you divide both, you are going to have 2 meters per second squared. Sorry, I ticked A. A is not the correct answer, please. D is the correct answer. So sorry about that. All right, let's go. I want us to finish this. All right, question 8 says, an aircraft flying at 335 meters per second passes over an anti-aircraft gun. How far has it traveled in 5 seconds? In 5 seconds. How far? How long? Those of you that used to ask your friends, how far? I hope you know that you are committing grammatical blunders. How far? How far has to do with distance. How long has to do with what? Time, correct? Correct. So this question is asking us how far, which means it's asking us of distance. It's asking us of distance. Please, as a student of physics, you must know this. So these small things can bring confusion, a serious one in exam hall. How far? How long? Instead of them saying calculate the distance, calculate time. No, how far? How long? Do you see it? I hope my people are getting me today, because today you see we are dealing with tough challenges. Yes. If you don't understand, watch the video again, get it clear. Yes, after watching it for the first time, just give yourself a break. Go and take cool water or soft drink or something, rest a little, come back. Insist that you must understand every point I've explained. In fact, if it's still not clear, reach out to me. If you are in my group, you know how to access my you know how to access me. Just send me a DM. I will attend to you. All right. If you are a new student, you are just joining and you are watching and you are not subscribed to my channel, I don't know. Let me not say you are still not yet serious, but then I think the value I'm giving is enough, is good, and you can do well by subscribing so that you can have access to other materials I've been sending. Like and share with your friends. Thank you. So we are calculating distance here on question 8, and the distance formula is always equal to what? Speed times time. Speed times time. That is the formula for distance. So we are given speed already, and we are given time. What next? Just multiply. Simple. Now, I always want you to know this other side of questions. For example, this year, they may decide to give you distance, they may decide to give you time, and ask you speed. Now, look at the same formula. Distance is given, time is given, but they will now decide not to give you speed and ask you to calculate speed. Will you be able to manipulate the formula to calculate speed? Yes, I trust you. How do you do that? You either substitute the values directly, you put your distance, then put your time. You can put S as speed, or whichever thing. You can even write it completely as speed. So you divide both sides by time so that you can get the speed. You divide both sides by time. If you like, you can divide it right from here to make speed the subject of formula, and then you can calculate your speed. So it means that speed is equal to distance per unit time. Distance over time, that's speed. That's speed. All right, thank you. Just know how you can manipulate, how you can maneuver, how you can change the subject of formula, how you can rearrange the formula to get what you want. I really want you to master this very well. Maybe one of the days, if I'm able to get space, I will find a whiteboard and do some illustrations for you on that. Thank you. Okay, let's answer the last question. So the last question says, why is the acceleration due to gravity not constant everywhere on Earth? It's not constant everywhere on Earth. It's not constant everywhere on Earth. All right, we know acceleration due to gravity. And why is it that it's not constant? Now, on Earth, the acceleration due to gravity is almost the same everywhere you go to, but not exactly the same. There is variations in some locations. That's why 9.8 sometimes is used. You know, they use average. Let's say you measure the acceleration due to gravity in Nigeria and it happens to be 10. You measure it in US and maybe you get 9.2. You measure it somewhere in Europe and maybe you get 10.5. You measure it. So by the time you take different measurements across the globe, you put them together and find the average. So that average is used. So even if there is this difference, it's a little, just a little. It's not a big difference across the globe, but there is difference. So what's the reason for this difference? The reason is because the Earth's rotation causes a centrifugal force. We have answered the question on centrifugal force. I said when an object is moving in a circular motion, there is a force we call centrifugal force acting on this object. All right. So the reason is because there is centrifugal force, and this reduces gravitational or acceleration due to gravity slightly at the equator compared to the poles. So at the equator, the acceleration due to gravity is reduced slightly compared to the equator. There are several questions around this question. I've once seen a question where they said two persons are boiling water, one at the top of the mountain and one in the valley down the mountain. So they are applying the same amount of heat, but it was observed that the one boiling his water at the top of the mountain, the water happens to boil faster than the one at the bottom of the mountain. What is the reason? What is the reason? So the pressure has to do the reason has to do with atmospheric pressure. So those that are deep down, they experience more of pressure than those that are on the mountain. So if you are high, on the higher altitude, the pressure is lower compared to those that are at the bottom of the mountain. And don't forget, pressure has to do with the gravitational field also. Yes, it's connected to gravitational field. I may not be able to explain this, but in case you see something like that, the reason is because the pressure at the mountain is lower compared to the pressure at the bottom of the mountain. So I will stop at this point in time. If you have not subscribed yet, you have not liked, I don't know what you are waiting for. I believe you have learned something. So like, so that others will also benefit from this. By the time you like, you subscribe and you share or you commented on this video, it will help many other people to see. It will make YouTube to share it to many other people. So please like, subscribe, and follow for more important content and to help YouTube, to help me reach out to more students. I still need to reach out to more. So please like, drop your comment. I also want to hear a feedback. If my explanations are simpler, if you are getting it, if there is something you did not get, if there is something you feel I should do better next time, just give me feedback. See, it helps me a lot anytime you give feedback because it will help me to try to see what I need to add next time to make you understand better. That's my goal. If you don't understand, I'm wasting my time now. So I want to hear your feedback. Let me know if you are getting it. So do well to drop a comment in the comment section as soon as you finish watching this video. Let me hear the areas I need to improve. Let me hear if I'm doing well so that I will keep doing what I'm doing. Thank you so much. All the best. Keep your eye on my channel for the next video, most likely tomorrow. Thank you and God bless you.